Excuse my handwriting, I don't know if you guys can read that. But in this video, we're going to be doing some logarithmic equations after learning our rules and the change-of-base formula. So this says, if you can't read it, my apologies, log of 16 plus 2x is equal to log of x plus log of x minus 4. What do? First, no, this is the common log base 10, so we can't really do some simplification here in terms of the powers of 2. So let's have a look. Well, this addition right here, we know this. We can use the addition rule that we learned. So what we can do is we can multiply these two things together. So on one end, we still have log of 16 plus 2x, ooh, I almost put that as an exponent, is equal to the log of these two things multiplied. So x times x is going to be x squared. And then we're going to have minus 4 times x. Now, these two things are both nested within a log. That means that we can get rid of them. Because this is asking 10 to what power is equal to that? 10 to what power is equal to that? They're both asking 10 to what power is equal to that, meaning they're equivalent statements. So this is the same thing as just having 16 plus 2x is equal to x squared minus 4x. All right, simplification time. We're going to drag everything over to the other side. So minus 2x minus 16. So all in all, we're going to have x squared minus 6x minus 16. All right, quadratics time. You guys can do this in your sleep. What multiplies to 16? Adds to negative 6. 16, first number pops in the head. 8 and 2. So which one of them has to be negative in order to get negative 6? Well, we need the bigger number to be negative because we're still in the negative world. So our two numbers, I'm just going to write these down, are going to be negative 8 and 2. There we go. So on one end, we have x minus 8, x plus 2, meaning our x's are equal to 8 and negative 2. Are you guys seeing what I'm seeing? Something is amiss here because we cannot have a negative number in the base. If we plugged in negative 2, this would be as, I don't know if you guys can see up here. No, I'm not gonna. Let's put it right here. Log of negative 2 is equal to what? This is asking 10 to what power is equal to negative 2? 10. A positive integer, no matter how many times you multiply it by itself, is never going to be negative. So yes, this is the return of the extraneous solution. So negative 2 does not work, meaning our only solution is positive 8. Boom. New equation. Log of x minus log of 2 equals 1. Subtraction rule. Let's go. This means that we can change this into a division statement. Log of x minus log of 2 is the same thing as having log of x divided by 2, and that is equal to 1. Now, we can rewrite this into a regular exponential expression. So log, this is the common log, so we know that this is really log base 10. So 10 to the first power is equal to x over 2. 10 to the first power is just 10. So we have just, I'm going to make this bigger, is equal to x over 2. So now, simple algebra, multiply both sides by 2. These cancel. So we get 20 is equal to x. we have lots of equations almost breaking the barrier here and also being equal to 1. But I do this because we're going to have a lot of work. And I'm not in the same room that we were in last time because somebody booked it before I did. So, just read it if you can't see it. Log base 8 of 2 plus log base 8 of 4x is equal to 1. Off the top of my head, nothing really clicks. So why don't we simplify this right here? Because this is multiplication right here. We can break that up. Because this is going to be log base 8 of 4 plus log base 8 of x. So on one end, we have log base 8 of 2 plus log base 8 of x. No, not x. I want to do 4 because I want to keep my constants all close to each other. And I'll have my x over here. Plus log base 8 of x is equal to 1. Okay. Very long, but I promise we're going to simplify it. Let's think here. We have a big number in our base with a smaller number in our argument, meaning that 8 is going to be raised to a rational exponent because we need it to get smaller. So, what is the relationship between 8 and 2? Well, 2 cubed is 8, which means the cube root of 8 is equal to 2. So 8 to the cube root, which is 1/3, is equal to 2. So that right there is just going to be 1/3. Now, log base 8 of 4, let's think again here. The cube root of 8 is 2. 2 squared is 4. So if we took the cube root of 8 and then square rooted that, that would be equal to 4. Meaning that we have the cube root times 2. Or raised to the second power, meaning that the exponents get multiplied. So log base 8 of 4 is just going to be 2/3. Now that is simplified, 1/3 plus 2/3, that's just 1 because we get 3/3. So this is really just 1 plus log base 8 of x is equal to 1. Is it clicking yet? So, -1, -1, because I want my x on its own. So, we subtract, which means these erase. Or I'm going to keep this here just for clarity. But this just becomes 0. So on one end we have 0, and on the other we have log base 8 of x. Which rule of ours do we know that solves this? 8 to the 0th power, any number to the 0th power, is going to be 1. X is equal to 1. Boom. Now, this is a very nasty looking equation. Lots of 2's on one side, but 14 is not a power of 2. What will we ever do? Well, the first thing is that we have a 2 on the outside of the log, which means that we can divide this. So let's divide this one side and this other side by 2. I don't want to ruin this, so I'm just going to put it right here. Divided by 2. Divided by 2. So these two cancel. And 14 divided by 2 is equal to 7. Is equal to log base 2 of x squared. Y'all see that? Is it too small? Yeah, you can see it. Well, now what? Let's have a look here. I think what's best is to rewrite this and see what's going on. 2 to the 7th power is equal to x squared. And now, I think it becomes quite clear, the next step is to square root both sides, because we want to undo the squaring, so we get x on its own. So we have the square root of 2 to the 7th power is equal to x. Now what? Well, the simple way of explaining having exponents inside a radical is that, here, let's rewrite the radical actually to show this in more detail. Because this is just 2 to the 7th all to the 1/2. That being 2 to the 7/2. What I'm going to do, I'm going to take a whole number out of this. Because if we take a whole number out of this, that means we can drag it out, and that's just being multiplied by the rational exponent. So 2 to the 7/2, that's the same as having 2 to the 6/2 plus 2 to the 1/2. Because when you have a common denominator here, so we can just add these. So we get 7/2. 2 to the 6/2, that's just 2 cubed, which is going to be 8, plus 1/2. Now, when we have addition up here, that means that we're going to be multiplying 2 by whatever that is, which is just going to be the square root of 2. So x is equal to 8 times the square root of 2. Keep mathing.